and welcome back to Maths Behind the Economics YouTube channel. In this video, we will talk about what happens if we multiply two different bases, but we raise them to the same exponent. Remember, in the second video, we done the opposite. We had same bases multiplied to different exponents, so what's going to happen, what's going to be a different in here? Well, first I'm going to show you the rule. Then we'll talk about why the rule works, we talk about the intuition behind the rule, and again we'll do a formal proof, and then we'll look at loads of examples. So let's get down to it. Again, let's start with the rule first. When you have got two numbers multiplied together, any of those two numbers, let's say a and b, but you raise them together to the exponent n, that's exactly the same as a raised to the n and multiplied by b raised to the same power. Now, you have to be very, very careful here, because ab to the n is absolutely not equal to ab to the n. Remember, the brackets always tell us priorities. So in this case, what it tells me that I have to raise both of them, a and b, to the same power. And look, in here, it only tells me that b raised to n, not both of them. Right, so let's get down to and look at why the rule works. So why is it true? Well, let's, as always, just start with looking at number examples and see why it works in a specific case, what it means. So again, we can just break down the definition of the exponent. So what does it mean to raise something to the third power? Well, that just basically means multiplying that same thing, in this case 5 times 2, by itself 3 times. Well, when there's nothing in between brackets, that's always multiplication. So I can rewrite this as 5 times 2 times 5 times 2 times 5 times 2. One more thing that we need to remember when we do the multiplication is that the order of multiplication can be changed. So, for example, I can switch these two, and I can switch these two, and I can switch these two all the way around. So I can rearrange this same multiplication in the way that it would be 5 times 5 times 5 times 2 times 2 times 2. And at the end, again, I'm just using the definition of what an exponent is. I've got 5 multiplied by itself 3 times. That can be replaced by 5 cubed. And again, I've got 2 multiplied by itself 3 times. That can be replaced by 2 cubed. Well, there you go. So, how does it look like in the generic case? I'm going to make a little bit more space so we can see what's going on. I'll keep the rule up there. So, what's going on in here? So again, I've got ab to the nth exponent in this case. So it's not a specific number, not a specific base. Remember here at the top, 5 times 2 cubed, that was just one specific example. For this identity to hold, or every single number, we have to show, we have to demonstrate, we have to prove that there was nothing special about 2 or 5. We have to demonstrate that it works for any numbers and any exponent. So we use letters instead of specific numbers. Now again, we just use the definition. And this is just going to be AB times AB times AB. Again, we have this n times. So we can rearrange it. I'm going to write here rearrange. We can rearrange it using the properties of multiplication. So we can just rewrite it as a times a times a, and then again times b times b times b. How many a's do we have? We have got n of them. And how many b's do we have? Again, we have got n of them. So again, we use the definition of what an exponent is, and this whole thing can be just replaced by a to the n multiplied by b to the n, right? I hope that you like the idea. One last thing, When it comes to letters, we don't always write out the multiplication sign, so sometimes you just see it A-N, B-N. Again, remember, if there's nothing in between letters or brackets per se, that's in mathematics always, always, always multiplication. Okay, right. Let's again make some more space, and now let's get down to do some examples. The first one of the examples is 4 times 7 altogether raised to the 5th power. Now that's just simply 4 to the 5th times 7 to the 5th. Now that's perfectly fine, we can leave it as it is. However, if you are working with numbers or you're trying to figure out the final answer to some kind of calculations, you would actually put this into the calculator and you would give me one specific number solution. I'm just going to leave them as it is because the point here is to practice this rule, not to use the calculator. Minus 3 times 2 altogether cubed. Well, that's just going to be minus 3 cubed times 2 cubed. And again, I can replace that with minus 3 cubed times 2 cubed. Now, in this case, I do have to write out the multiplication sign because there's a difference between 3, 2 and 3 times 2. The two things are not equal. So 32 not equal 3 times 2. So you have to be quite careful. You can leave out the multiplication sign when you work with letters, but it's best not to leave them out when you work with numbers. Next example, 2x to the 7th. Now again, there is nothing in here. It means that I'm multiplying 2 and x together. When you raise them to the power together, that means you have to raise 2 to the 7th first, and then you put x to the 7th next. Okay, again, I don't have to do the multiplication sign in here. I could write it like 2 to the 7 times x to the 7. But now here, because you've got the multiplication sign and an x is a little bit similar, sometimes it can get a bit confusing. So maybe in this case, it's easier to leave out the multiplication sign. But as I said, nothing wrong in here, keeping in a multiplication sign. So next example, 7s squared. That's just 7 squared times x squared. So again, we just raise them to the same power but separately. Next example, 3ab to the 4. Now, the rule is only talking about 2 terms when you have got ab together raised to the nth power, not number and 2 letters. But as in previous examples, we can do them in 2 stages. So I can do 3 to the 4, and then I can do ab to the 4th, and I can apply the rule again. So that would be 3 to the 4, a to the 4, and b to the 4. So you can break down the calculation into stages. First, you decide which 2 you want to apply to it. In this case, we did the 3 and the ab, and then we apply the rule again to the ab. So next time, when we're going to do 3 terms, we can just do straight away and apply them term by term. So what happens next is 9 times 5 to the 0. Well, that's just same as 9 to the 0 times 5 to the 0, but we know that anything to the 0 power is always 1, so that's just going to be 1 times 1, which is 1. Now, I can think about it slightly differently. Let me write that down again. 9 times 5 to the 0. I can think about it slightly differently. Doesn't matter what's inside the bracket, because what I know is that any number whatsoever raised to the 0 power will always, always, always give me 1. So I don't even have to think about and don't even have to bother about breaking it out into individual multiples. I can just straight away replace it with 1. Okay, I hope you like these examples. I hope you learned something new today. Thank you for being here and see you in the next video. Bye.